All right, today we're going to talk about the properties of exponents, which is a review from algebra class, so it should look fairly familiar to everyone when we go through this. So the first property that I want to talk with you guys about is known as the product of powers. And the actual definition for the product of powers is a to the m power, all right, times a to the n power. And here's what happens. When you have a to the m power times a to the n power, what you're really going to do is you're going to take your two exponents and you're going to add them together. Okay? For example, if you have, x to the 7th power times x to the 2nd power. Well, you know here what you have is you have x times x times x times x times x times x times x. We need one more. That is x to the 7th power. And then this right here is x to the 2nd power, so you have x times x. Now what happens is when you go ahead and you take all these x's and put them together, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. That is why you take and you add those together. Okay, so you end up with x to the 9th there. So that's a product of powers. Power of a power. Okay, this one, a to the m power, and then it's raised to the nth power. And what you actually do for these is you take and you multiply the m and the n together. Okay, an example is something like this: x to the 4th power, all right, raised to the 3rd power. And that would equal x to the 12th because you multiply those two things together. Here's why. You have x to the 4th times x to the 4th times x to the 4th. You have it 3 times. And we know whenever we go ahead and multiply x to the 4th times x to the 4th times x to the 4th, we're going to add those exponents. I have 4 plus 4 plus 4, which would give me 12. Okay? Power of a power. Number 3, power of a product. All right? Power of a product, what you have for that one is you have a and b, all right? And those are your bases there, all right? Raised to the m power. What you actually do with this one is you take that m exponent and you distribute it, a to the m power and b to the m power as well. Okay? For example, let's say you have 3x to the 3rd, all right, and then you have y squared, and it's all raised to the 4th power. All right, what's going to happen is you're going to take this, and you're going to distribute here, you're going to distribute here, and you're going to distribute here, and you're going to use your other properties now. Okay, so this one would be 3 to the 4th power, and then you have x to the 3rd to the 4th power. So you're going to use the power of a power, so you're going to end up with x to the 12th. All right, and then you have y squared raised to the 4th power, so that's going to give you y to the 8th. Okay, now 3 to the 4th, that really means 3 times 3 times 3 times 3. So 3 times 3 gives me 9, times 3 gives me 27, times 3 gives me 81. So I end up with here as a simplified expression, 81 x to the 12th power, y to the 8th power. All right? All right. The fourth property of exponents is known as a negative exponent. So let's say you have this, a to the negative m power. That's the same thing as saying 1 over a to the positive m. All right? So, for example, if you have, let's go with, 2x to the negative 3rd over y to the negative 4th power. Okay? In this example, this negative 3 goes with this x here. It does not go with the 2. All right, that's the exponent for that variable. So what happens is you're going to take this and you're going to move it down to the bottom. Okay, and it's going to become positive. You're also going to take this and you're going to move it up to the numerator. Okay, so when you rewrite this one now as a simplified expression, it should be 2y to the 4th. You moved it from denominator to numerator, and then you have in your denominator x to the 3rd. Okay? Fifth property of exponents, all right, is known as the zero exponent property. All right? A to the 0 power is equal to 1. No matter what you have to the 0 power, it's equal to 1. Okay? And the reason for this is, let's say you have, like, x And I'll get into that in a minute. Let me erase that. All right. I'll show you why in a minute. Okay, so let's say you have like this. 3x to the third, y to the negative fourth, z to the fifth power, and all of it is raised to the 0 power. All right, well, what you'd have to do is you'd have to distribute this in here, and here, and here, and here. But you know when you multiply all that together, you're going to end up with 0 for all of them. So this whole thing right here is equal to 1. Okay? And the reason for that is because of the quotient of powers. This one says if you have a to the m power, right, and you have a to the n power, what you're really doing when you divide is you're subtracting your exponents, a minus n. Okay? Example. All right, an example would be this. Y to the 7th over y to the 3rd really means y times y times y times y times y times y times y all over y times y times y. All right, and we know what we can do here is we can cancel out, and cancel out. So we're really left with y to the 4th power. 1, 2, 3, 4. All right. So why wouldn't it be easier just to say y to the 7th minus 3 gives you y to the 4th power? Okay. Now, I wanted to go back and talk about how this affects this up here. Let's say you have something like this. 5 to the 3rd power over 5 to the 3rd power. Well, we know we could take, since we have this rule, we could subtract those two, and we could end up with 5 to the 0 power, which we know is equal to 1. And I wanted to show you here, if you have 5 times 5 times 5 over 5 times 5 times 5. What's 5 divided by 5? Well, that's going to be 1. What's this 5 divided by that 5? 1. And this 5 divided by that 5 is 1. All right? So you really have 5 times 5, which would equal 1. That's why anything to the 0 power is always equal to 1. Okay? All right. And the 7th property is called the power of the quotient, and that one is a over b, all raised to the m power. Okay? A to the m over b to the m. Okay? For example, let's say you have 3x to the 3rd over y to the 7th, all raised to the 5th power. Okay? What happens is this 5 goes with the here, goes here, and goes here. So really what you have now is you have 3 to the 5th power, y to the 15th, because you multiply those two together. Excuse me. Not y to the 15th. My exponent, excuse me, my variable up top is an x. So I have x to the 15th all over y to the 21st. All right? 3 to the 5th means 3 times 3, which is 9, times 3 is 27, 81, and you end up with 243 x to the 15th all over y to the 21st. Okay? Guys, these are your properties of exponents right here. You're going to use these to go ahead and apply them to anything where we have to simplify when we have variables and exponents and that type of stuff. Okay? We'll get into section 5.2 coming up tomorrow.